Hi everyone, in this video we look at stretches and compressions of functions. So in the last investigation we looked at the graph of f of kx being either a stretch or a compression of the graph of y is equal to f of x, and it's a horizontal, it's either a horizontal stretch by a factor of 1 over k, or it can be a horizontal compression by a factor of 1 over k. If k is between 0 and 1, then a stretch is going to be performed. If k is greater than 1, then a compression is performed. And we also looked at the fact that when k is negative, this results in a reflection about the y-axis as well. So what does that mean? Well, it means that if x comma y is on the graph of y is equal to f of x, then the point x over k comma y is going to be on the graph of y is equal to f of kx. We can, if we know a point x comma y on the graph of f of x, we can figure out a point on the graph of f of kx by doing by mapping this point to x over k comma y on the graph of f of kx. So this is easiest or best understood through example. So let's look at the graph of f of x is equal to root of x. So I know that the key points on the graph of f of x is equal to root x would be, let's see here, this is my x, these are my x values, this is my y value. I know that 0 comma 0 is on the point of root of x. I know that 1 comma 1 is on the graph of f of x. I know that 4 comma 2 is on the graph of f of x, and 9 comma 3 is on the graph of f of x. So we can graph the parent function here, and the parent function has these key points. So 0 comma 0, 1 comma 1, 4 comma 2, and 9 comma 3. All of those points are on the graph of f of x. So this is f of x, which has the equation equal to root of x. Now let's think about g of x. So this g of x let's think about the different outputs that g of x has. Well, since I know that the square root function, when I have 2x being equal to 0, the function is going to output 0. When 2x is equal to 1, the function is going to output 1. When 2x is equal to 4, the function is going to output 2. And when 2x is equal to 9, the function is going to output, the output will be 3. Because g of, if I do the square root of 9, I get 3. If I do the square root of 4, I get 2. If I do the square root of 1, I get 1. And if I take the square root of 0, I get 0. So now let's think about what values of x actually give me the square root of 0. So the question is, when is 2x equal to 0? And the answer to that would be, well, 2x is equal to 0 if x is equal to 0. When is 2x equal to 1? Well, 2x is equal to 1 when x is equal to 1/2. When is 2x equal to 4? 2x would be equal to 4 when x is equal to 2. When is 2x equal to 9? Well, 2x is equal to 9 when x is equal to 4.5, or 9 over 2. So we can see what happens here. We get the same y values, but now all of our x values are divided by 2. So we've divided all of the x values of f of x by 2 to get the x values of the transform points on g of x. So let's go ahead and we'll graph those points, and let's see what this looks like. Well, I've got a point here, a point here, a point at 2 comma 2, which is here, and I have a point at 9 over 2 comma 3, which is right here. So what happened here was that the coordinates of or these points on f of x were compressed horizontally by a factor of 1/2. So this is the function g of x, which is equal to the square root of 2x. And we can see how these points were compressed horizontally by a factor of 1/2. Let's go ahead and we'll kind of do the same thing for x, or for h of x. So when x is, let's think about the different outputs here. We have 0, 1, 2, and 3. And let's think about what x values produce these outputs. So I get a output of 0 when, for h of x, when x over 2 is equal to 0. So when is x over 2 equal to 0? When x is 0. When is x over 2 equal to 1? Because when I take the square root of 1, I'll get 1. So when is x over 2 equal to 1? And the answer to that is when x is equal to 2. Similarly, if I take the square root of 4, I get 2. So when is x over 2 equal to 4? When x is equal to 8. Lastly, when is x over 2 equal to 9? And the answer to that is when x over 2 is equal to, or when x is equal to 18. So here, you can see that the x values on the key points of h of x are related to the key points, or to the x values of the key points on f of x through multiplication by 2. So these points are, if you multiply the x values of f of x by 2, you'll get the x values of the key points, or the transform points, on h of x. So let's go ahead and we can plot all of the points in this table of values. We have 0, 0, 2, 1, 8, 2, and then we'd have 18, 3, which is actually off of the grid here. It's outside the frame, so we can't graph that point based on how this grid is scaled. But you can still see what's happening. This point stays in the same spot. This point is stretched horizontally by a factor of 2, and this point is stretched horizontally by a factor of 2 as well. So h of x, which is equal to the square root of x over 2, is a horizontal stretch by a factor of 2 of f of x. So that's how the two graphs are related. So we can see that when k is between, if k is between 0 and 1, which was the case for h of x, we get a horizontal stretch. When k is greater than 1, which was the case of g of x, we get a horizontal compression by a factor of 1 over k. So this is a horizontal stretch by a factor of 1 over k, and this is a horizontal compression by a factor of 1 over k, as was summarized above.